Recording. Yeah, so Tuesday is going to be a review for the final exam. Please come with specific questions. It's going to be like the first review session we did, wherein I will answer specific content related questions rather than focusing on like lecturing to you, right? So please come with specific questions about the material, and I'm happy to answer those as they come up. Yeah, so we are in the home stretch here. Today's lecture, let me actually pull up the slides. Excuse me. Today's lecture is my bread and butter of human factors. Where did I? Sorry, I'm not good at multitasking here. Get to those actual slides. All right. So at the beginning of the semester, I asked all of y'all who was a psychology major or was thinking about being a psychology major. And I'm interested if anybody who didn't initially say they were a psychology major has thought that they may want to add it as a major or as a minor. If so, let me know in that chat box. It's obviously not going to affect anything about the class. I'm just curious as to who has been thinking about it. You know, one of the things that I loved in college was taking a lot of the other courses. I took an astronomy class just because I thought it would be interesting, and then wound up loving astronomy so much, I wound up minoring in it. So that's one of the cool things about a liberal arts education. But yeah, if any of y'all do have questions about the process of becoming a psychology major or a minor, please feel free to shoot me an email and we can find time to chat about it. All right. So we are talking about human factors today. But before we get there, any questions about what we covered last time or questions about the course, final exam, etc.? All right. No questions coming in, but feel free to finish typing them up and I will answer them as they come out. Oh, there we go. Is the final going to be open during the scheduled time or for an extended period, like a couple of days? No, it will be just for the time period that we have allotted, that we have scheduled. And I don't remember off the top of my head when that is. That's publicly available, but I will let everybody know when it'll be. You will have the full 2.5 hours. Again, it probably will not take anywhere near the full 2.5 hours, but you'll have it if you need it. And it will be open for just those 2.5 hours. So if you show up an hour late to start taking it, you will only have 1.5 hours to take the exam. Good question. All right. Any other questions, just go ahead and type them into that chat box. I feel like I've already given you this fun fact of the day. Excuse me. So I'll give you another one after this. But bones found at Seymour Island indicate that 37 to 40 million years ago, penguins stood at a formidable 6 feet tall and weighed 250 pounds. Your ancillary fun fact of the day is that apparently as recent as potentially 4,000 years ago, giant sloths, ground sloths that weighed about 4 tons and could measure between 16 and 20 feet long, roamed the earth. Now, they weren't tree sloths like we know today, but they were ground sloths, and apparently they did move slower. So one of the reasons that we think they may have gone extinct is early humans hunting them for meat. So there you go. Lots of massive, terrifying creatures that seem cute and small today. All right, so what is human factors engineering? Well, from my perspective, based off of my research, I define human factors engineering as making technology work for people, right? There are a lot of other domains within human factors that we'll talk about throughout the lecture today. But I'm principally interested in technology, right? And so if you think about your smartphone, for those of y'all that do have a smartphone, so much of your interaction with the phone seems kind of just intuitive, right? If you want to do something, you try to do it, and it usually winds up working. And that's not a coincidence. It's because of hundreds of hours of user testing that companies like Apple are able to design systems and products that are uniquely suited for the human, for the individual, right? So things that are pleasant to use, things that are easy to use. And then we will also talk about safety. Thinking about things also like these controllers from the HTC Vive. So the HTC Vive is a virtual reality headset, and the controllers themselves are used to help navigate you in the environment, to interact in the same way that video game controllers typically do. And so absolutely human factors engineering goes into the actual design of these controllers, but also things within virtual reality. So for example, old virtual reality video games used to involve you walking around, like with you had a joystick, and so your character would walk around in the environment. But one of the things I noticed is that you get this disjointed experience between the visual input and your proprioceptive input, right? Because virtual reality is all encompassing. You're getting really comprehensive information about you walking, and yet you're getting no inner ear feedback from your proprioceptive system about moving, right? And so that disjointedness led people to have kind of simulator sickness or feel, sort of motion sick. But they realized that if they just kind of had characters teleport to different areas, right? So you will click on an area and your character will just kind of flash and appear there. They can help combat some of that. And that's human factors engineering at work. And then it's also important to remember that even in really advanced programs and technologies, human factors needs to be considered, and it's not always considered. So what you see here is the F-35, and it's brand new cutting edge technology. It is the newest fighter aircraft in the US military's arsenal. Stealth fighter has an incredible amount of technology in the cockpit, including sensors and augmented reality displays and things like that within the pilot's helmet, right? This is a multi-billion-dollar project sponsored by Lockheed Martin. Really cutting edge. Everybody was excited about it. And then they delivered the first product. And what people realized was that the helmet was so heavy for the pilot that should the pilot have to eject, their neck would likely snap because of the weight of the helmet, right? And so you have this incredibly expensive, incredibly advanced project wherein basic fundamental aspects of human physiology and anatomy weren't considered for the actual user. And so that's where human factors engineers come in. It's helping engineers understand that no, you can't just design the system however you want. You need to design a system that works for the user, for the individual. And so there are three main focuses or foci within human factors engineering: to enhance safety, to enhance performance, and to enhance satisfaction, right? And so when we talk about safety, sorry about that. When we talk about safety, we're talking about the reducing of risk of injury and death. Performance would be increasing the productivity, the quality of the output, and the efficiency of the workers. And then satisfaction, so increasing the acceptance, comfort, and well-being, enjoyment, essentially, of the use of that product. Leave it to the dogs to start barking once we start lecturing here. And so you can think about the relative importance of these three different criteria in various domains. So in high-risk domains, you may prioritize safety over performance and satisfaction, right? While you still want to enhance performance and still want to enhance satisfaction, what matters most is enhancing the safety. And sometimes the enhancement of safety comes at the detriment of actual performance. In various workplaces, you may still want to have some focus on safety, but what you may really be what you may really be interested in is enhancing the performance of the workers, the assembly line workers. You may not care so much about satisfaction. Really what you care about is that output. However, with things like consumer products, what you may care about is the actual satisfaction enhancement rather than necessarily the safety or performance, right? You still then have to put some emphasis on safety. But really, people who are buying products are buying them because they enjoy them, right? So they feel like it enhances their well-being, their overall lot in life. Sometimes they'll care about performance, but frequently they're going to care about the actual satisfaction inherent within that product. All right, so I would normally have us discuss this in class, but somebody give me a way in the group chat of how they would determine if they were called in to consult where we should put the emphasis. Should it be on the safety, on the satisfaction, or the performance? Someone's got to have an idea here. Especially those engineers of you who may be called in to consult with a company. How would you decide what we need to prioritize, safety, satisfaction, or performance? Okay, so Jaleesa, you think it would just be blanket safety, safety would be the most important thing? Yeah, and so potentially it would be, right? So it could be the case that anytime you're coming in to consult, what you really need to be concerned about is the safety of the work environment. However, there are certain circumstances wherein you don't necessarily need to fixate on the safety. The reason you may be called in to consult would be because they need to enhance the performance of the workers, right? Maybe workers are just not doing all that well, or maybe they're just not happy and there's a lot of turnover. And so, it's not always the case that, going into a workplace means that you have to focus on the safety. And in fact, there could be kind of due to preventing future lawsuits. Yes, absolutely. Do you want to be a lawyer there, Jaleesa? Oh, okay. Well, yeah. So you can think about the safety aspect, but also thinking about, okay, there are certain regulations, especially in the U.S., that require adherence to safety procedures, right? And so let's assume that the safety environment or the climate is ideal. What are some of the things you may need to focus on? Well, you could have satisfaction that's actually driving perhaps poor health outcomes, right? And so low satisfaction, job satisfaction, can result in poor coping behaviors, right? Drinking or smoking, or just general levels of stress. And so, yeah, and so scenarios like hoverboards, absolutely, you would have to get rid of. But you have to think about what is the trade-off that's coming in, right? Is the bottom line being affected by poor quality? Well, if so, maybe you need to think about, okay, what are the different features that we could change in the company to enhance that actual output of that widget, of that set widget, right? And so you have to think about it really as a trade-off, not just necessarily as a blanket response. And so, um, there are those trade-offs. It's not always possible to maximize performance and safety, for example, right? Wherein you are enhancing safety, you probably are going to have some sort of detriment in the actual performance, and vice versa, wherein you have enhanced performance, you frequently have low safety ratings. Not always the case, but you do see sometimes companies who prioritize performance over safety and then have uh, catastrophes that happen down the line. And so, as with any design process, the human factors design process is very circular, right? You create a project or a response, you evaluate it, you attempt to understand that data, and then you recreate, right? And so it's a constant iteration process. It's not just a linear one and done, right? It's a constant process of improvement. And that's why all of you on your computers likely get updates, notifications about available updates on software, because that's what these companies are doing. They push out the software, they realize, they evaluate the overall performance and the satisfaction, they try to understand what the problem is and how they can fix it, they create a solution, they continue to evaluate, understand, etc. And so it's a continuous iteration process throughout the life cycle of a product and a company. And there are a lot of things that go into this actual consideration, right? So there's system properties and human characteristics that need to be considered, right? The system as a whole, and we'll talk about systems engineering in a little bit. The cognitive states of the individuals, the users, the workers, the physical conditions, and then also the social conditions. And we'll talk about how these come into play in a little bit. And so in this kind of cycle, this circle, we have to develop that understanding. Sometimes that understanding comes from an accident investigation, right? And so you'll have human factors engineers called in after, for example, an airline crash to try to understand what in the world happened. It could just be an observation, whether you are on the floor deliberately trying to observe things, or you get the observation from workers, or you're called in to observe the product, the plant itself, or observe users using it. Or you can perform, for example, a task analysis, right? And historically, one of the kind of most quintessential individuals who was doing this sort of task analysis was a man with the last name of Taylor. And that's where you may hear phrases like Taylorism come from, who was principally focused on enhancing the efficiency of workers. Was famous for walking around with a stopwatch to enhance the productivity, to find where all these inefficiencies were in the actual system. And once you develop that understanding, you then create a solution. It can be a task-based, it can be equipment-based, or environmental-based, training, selection, or organization-based. After you create that situation, you implement it, and then you evaluate the actual solution that you put into place. And it can be with a heuristic evaluation, right? And so a human factors expert comes in and based off of what they know about human factors, gives kind of an evaluation of that solution. Could be usability testing, right? And so maybe we push out an app and get user feedback and usability testing based off of various data and also subjective experience, or just a system evaluation as a whole. How well is the system now functioning in terms of that productivity, for example? And then you continue to iterate. And this iteration can take as little as a few minutes in these changes. It can be all the way up to actual years in the process, right? So, it's frequently the case that in these accident investigations, the investigation itself may take, let's say, 6 months. They come up with suggested solutions, and then they get to evaluate how those solutions are working, which then comes into play of revised solutions, right? So you're seeing this a lot with, for example, the CDC now of, okay, what do we understand? Let's create a solution that we think is reasonable based off of the data. Is it working? Okay, parts of it are working. What do we need to reiterate on and start kind of continuing to snowball in this iteration cycle? I'm going to pause real quick. If anybody has any questions, go ahead and type them into that chat box. All right, if you do have questions, finish typing them up and send them in. And so, like I already said, there are various types of solutions to the problem. A redesign of the task, equipment design or redesign, environmental redesign or design, training solutions, selection of personnel, and then also team and organizational structure and design. And we're going to go over each one of these in detail. So task design is changing what the operators actually do, right? And so let's say you go into a manufacturing plant, they're manufacturing widgets of some type, and one of the issues they're having is substantial back pain in their workers, right? And so one of the things you may do is make it so now they're not actually lifting heavy equipment, they're getting a robot to lift it, right? And so part of this could also be an equipment design, but change it such that now the operators no longer have to do these repetitive bending over and lifting of things that may be heavy enough to cause back pain. We are instead having a a different component of that task responsible for the lifting. And think about the Ford assembly line in here. So Henry Ford was famous for kind of revolutionizing this assembly line in keeping with Taylorism, like we just talked about, wherein he no longer had one person seeing the project from start to finish, right? So the person didn't start at the very beginning of the Model T and see it all the way through rolling off the assembly line. One person just started specializing in a specific task, right? So now maybe I'm responsible for assembling the door and mounting the door, whereas one of y'all would be responsible for putting together any sort of dashboard components, etc. And so now we've got this specialization that allows us to enhance our efficiency in the process. You can also have equipment design, so changes to the actual physical equipment associated with the people's task or their job. And this is one of my favorite examples of all time of a necessary equipment design. And so I think it was a French Air Force fighter was giving a ride to a civilian, and on takeoff, the civilian accidentally ejected themselves from the plane. And what they think happened is, embracing themselves for the takeoff, they reached under the seat to brace and hold on, but what they were holding on to was actually the ejection seat lever. And so thinking about, okay, what are the pieces of equipment that we need to redesign in order to prevent people from making specific mistakes? And so this can be redesign of equipment like that ejection seat. One of the other things that in the 20th century they were trying to do in cockpits was change the different levers to have different feels so people knew what they were going to do, right? And so knowing or being able to feel that the lever which controls the flaps on the aircraft is actually changing the orientation of the flaps. It feels like a flap. Having the lever that retracts or deploys the landing gear feels like a wheel on the very end of it, right? And so you've got this differentiation wherein you can feel the difference, and so you're less likely to think you have deployed the landing gear, but in reality, you've just changed the flaps, the flap orientation. You can also include new equipment, right? So you can design a robot to actually control and lift the heavy equipment that you have in that previous example we just had, right? And so it can be the inclusion of new equipment, or it can be the redesign of old equipment to be better suited such that humans aren't going to be able to make those types of mistakes. There are also changes to the environment that can be made where the tasks are carried out, right? And so you can think about the actual safety of workers. If you're in an environment wherein there's a lot of really loud noise for a sustained period of time, simply giving the workers, hearing protection will allow them to be guarded against any of the long-term damage to their hearing. But also, there's an interaction wherein long, sustained, loud noises can be really annoying, right? So you're reducing their annoyance, increasing their satisfaction by doing something like this. Or maybe you bring in an audio engineer who helps redesign the floor plan in such a way that it no longer is reflecting as much noise, it's absorbing a lot of the noise. You can also think about casinos. If any of y'all have ever been to a casino, one of the things you'll notice is that there are no windows and no clocks. And this is a design of the environment in an attempt to make you kind of dissociate from time. And so the goal is to keep you on the tables for as long as they can. And in so doing, they are removing any of the windows, removing any of the clocks, any of the indications of what time it actually is. Because the longer you're on the table, the more money you're likely to lose to the casino. You can also think about different environmental changes pertaining to, for example, temperature. And so maybe it's too cold or too hot. So we need to figure out some sort of mitigation so we can reduce the injuries and also heat casualties. And you can think about various environmental changes that enhance satisfaction like you have at these big companies, right? And so we'll talk about Facebook in just a minute. But what are the things I can change at Facebook to make people happier and more productive, et cetera? It's why you get these kind of startup, but also tech giant companies having a very specific atmosphere and feeling to them when compared to traditional stuffy classic businesses. You can also have training changes, right? And so perhaps one of the solutions isn't going to be changing the equipment, changing the tasks, changing the environment, but what you need to do is enhance the training that somebody gets. And so, you're enhancing the knowledge, but also enhancing the skills by preparing them for that job environment, right? And so one of the reasons, for example, boot camp can be so stressful is they're trying to train future soldiers, future Marine, future airmen, et cetera, to be able to perform under stress, right? And so this is a training aspect. It's not necessarily an environmental change. It's not really any equipment that's being changed. It's a training component to enhance the performance under stress down the line. You also get things like driving simulators, right? And so for all of y'all, when you started actually driving, I don't know the laws for every state, but at least it was the case for me when I was growing up. I had to take a driver's ed class. And so there was the knowledge component where I was actually in a class learning about the different rules of the road, different signs, different patterning, etc. But also there was a behind the wheel component where I had to actually get in the vehicle and learn to drive and then demonstrate those developed skills in an actual behind the wheel test. And the simulator you see here is actually a simulator housed at UAH. I think it's called the RIDE simulator. It's within the engineering department. And it's part of an Alabama Department of Transportation grant to look at essentially truck drivers, right? And this can be used to train truck drivers, but it could also be used to evaluate the training that truck drivers get. Obviously, when we put somebody in a big rig, we don't want the first time that they experience the idiosyncrasies of driving an 18-wheeler to be when they're driving an 18-wheeler, right? There are too many consequences associated with that. So can you train them in a simulator environment, right? A low-risk environment that allows them to start understanding the nuances of driving a big rig. And this is one of the reasons I find it so absurd that you can go to U-Haul right now and rent a truck, I think they go up to like 24 feet long, without any demonstrated capability of being able to drive a truck that big. Anybody who's driven a big rig is probably replete with examples of potential screw-ups. Not to sell out my dad here, but when he was driving I didn't even know, it wasn't that long, and it was like a 16-foot U-Haul truck. He once got it wedged up on top of that barrier that protects gas pumps at the gas station. One of my students yesterday's husband accidentally got the tow hitch stuck in asphalt when they were driving a big rig, or a U-Haul rather. And so having that training, having that ability to put people in the situation to develop their skills before they're actually responsible for the potential consequences of their skills is an important component, right? And so you can think about different jobs you've had where maybe you got really good training or really bad training, and how that influenced your performance, your satisfaction, etc. There are also selection changes that can be made. And so changing the makeup of the team or the organization by selecting people that are best suited for that job. And the actual selection process is going to vary by field. And so one of the goals with having people take, for example, the GRE, the GMAT, SAT, etc., is to try to have kind of a standardized selection process. So before I went to graduate school, I worked as an admissions counselor, and I had a wide variety of areas of territory to cover and recruit from that spanned all sorts of divides, city versus rural, rich versus poor, etc. And one of the things I noticed was that the GPA was fairly standardized across, or was fairly consistent across these different regions. But the standardized test scores varied wildly. And so, one of the goals of college is having people take the ACT or the SAT, or for graduate school, GRE, GMAT, et cetera, is to try to evaluate, what is their actual standing compared to other people, to enhance the likelihood that we are getting the good students we want here at UAH, to enhance the overall educational experience for the other ones in the classroom. This selection process can also include things like evaluation of personality, evaluations of grit. And so for those of you who aren't familiar with grit's this concept of essentially perseverance in the face of adversity. And so one of the best predictors of success at service academies and retention at service academies is an individual's grit, right? If they have high perseverance in the face of adversity, they're more likely to stay enrolled at the service academy and succeed, whereas those who have low grit are less likely to do so. But one of the idiosyncrasies about selection is you need to make sure that what you are measuring is A, in fact, predictive, and B, in fact, predictive for the job you are interested in, right? Me measuring grit for an artist position may not be all that relevant. What I'm interested perhaps is in an individual's creativity rather than their perseverance in the face of adversity. And this is one of the criticisms that come about with standardized tests like the GRE, GMAT, SAT, etc., in that standardized test scores are not really all that great at predicting much beyond performance on future standardized test scores. And so that's why you see some grad schools, some colleges even getting away from these standardized tests. But when you think about these different companies, when you go on the job market, you may have a series of questionnaires to fill out in addition to the actual interviews. And what they're trying to do is, hopefully with scientific backing, establish whether or not you have those skill sets or competencies, aptitudes that we are interested in as this company to ensure that you excel and succeed in this company. And then we have the team and organization design, right? And so changes in how groups of people communicate and relate to each other, provide broad view that includes organizational climate where the work is performed. And so the example I love talking about here is Facebook. So one of my good friends from college is a recruiter at Facebook, and I went out to visit him a year ago out at Menlo Park and got to see the Facebook headquarters, and they're incredible. I mean, they have everything you need there, from food and daycare and laundry the things you want. So they have an arcade, they've got a woodworking facility, they've got gyms there, uh, everything you could ever use. They have parks, they have areas for recreation, places to nap, phone booths, etc. One of these buildings, not displayed here, but has essentially an entire park on the top of it. It's kind of wooded and relaxing, and so you can go up there and feel like you are getting out into nature, even when you are in this highly and densely populated area. And so what they've tried to do is establish this sort of climate wherein people will stay at work. They've got everything they need at work, so they don't have to venture beyond, but also make it a really appealing climate to be at, right? A lot of these companies are competing with one another, with various startups. And so because it's so much more expensive to hire a new employee than retain an existing one, these companies really want to make sure that when they do get an employee in the door, that employee wants to stay and is doing a good job at kind of maintaining that balance, which would indicate a long and successful career at that company. All right, so I'm going to pause real quick. Let me know if you have any questions. Also, if y'all can think of any specific examples where you've seen one of these changes be implemented, either at companies you've worked at or companies, really famous, popular companies, let me know. I'd love to hear some examples. All right, well, I'm not seeing any questions, but if you do have one, keep typing it in and send it on my way. All right, so as we talked about, with these different focuses and concentrations in human factors, you can have different focuses on safety, performance, satisfaction, et cetera, with these different solutions throughout. And so an example for these high-risk domains wherein we would be promoting the safety would be things like aircraft cockpits, nuclear power plants, cars, military weapon systems, wherein we still care about performance and satisfaction, but what we really care about first and foremost is the safety. What other examples can you all think of wherein we may care about safety in these high-risk domains? Somebody give me an example. Foundries. Yeah, absolutely. I assume you're talking about like metal foundries or things like that. Absolutely. There are so many ways things can go so wrong in foundries that what you're really interested in is the actual safety in that environment, first and foremost. So you are not potentially having lawsuits, but also workers' comp claims and job loss, et cetera. Refineries, absolutely. Yeah, any of these really kind of potentially catastrophic environments, absolutely, you should be principally focused on safety, and then you can focus on the actual performance and satisfaction. So environments, whoopsies, environments where you may focus on the performance over the safety and satisfaction could be things like manufacturing lines, office workstations. Give me other examples. What else? What other environments may you focus on performance? Retail, yeah, absolutely. So maybe we are brought in to consult with a company, and we want to see, okay, what is the overall performance of perhaps the salespeople, or the performance of operations, right? Are we able to get enough people through the checkout lines? Yeah, like in the restaurant business as well, exactly. And so we're really caring about, there are obvious safety procedures we need to keep in mind, and that's why you have companies like OSHA, et cetera. Um, but we perhaps care most about that performance and that bottom line. And so one of the things you see with, for example, airlines right now, one of the reasons airlines are struggling financially, obviously they have to consider the safety, but you also have to think about, okay, what's the performance aspect? What's the bottom line? Um, on average, the airline makes, I forget the number, it's something shockingly small. It's a single digit number dollar per seat. It's like $4 per seat they make in profit. And so when you have these flights that are going empty, they're hemorrhaging money because they've kind of optimized the consumer experience, the satisfaction of not having to pay too much, and have tried to streamline the number of flights that they offer. But wherein they're still having to provide flight services, they are losing tons of money because of the number of employees that it takes to get a flight in the air, the amount of fuel, et cetera, right? And so thinking about, okay, what are these performance enhancements we can make in order to make perhaps that industry more sustainable in times of economic uncertainty like now. And then within things like satisfaction, so websites, games, smartphones, etc. What else might we think about satisfaction over perhaps performance and safety? Windows, yeah. You mean like the operating system? Yeah, for a second I thought you meant like glass windows, and I was trying to figure out who was deriving satisfaction from glass windows. But yes, Windows, the operating system, absolutely. Yeah, and so thinking about, okay, what is the user experience that we need to enhance? And that's why you've seen such a dramatic change in the Windows operating systems over the years, both in look and functionality, et cetera. And so, uh, you know, the career field within human factors, it's going to focus on that overall satisfaction is that user experience and user interface. It's really high demand within the tech sector, right? They want to be able to develop products that people want to use, um, even sometimes at the cost of, for example, performance, right? And so nobody's going to argue that Apple products offer the best performance for the dollar, right? There are a lot of other products that offer substantially better performance for the same cost. However, there's a satisfaction component associated with Apple products. It's why I use Apple products, right? The ecosystem, they've done a really good job of that user experience, making things really easy for me to transfer from my Mac to my iPad, etc. And so focusing on the actual satisfaction can enhance that bottom line for those companies, but also make um, developed a sort of brand loyalty, right? The iPod was not the first MP3 player out on the market, but it was the one that dominated the market because of the satisfaction associated with the entire Apple ecosystem and how easy they made it. Excuse me. And so human factors itself is really a combination of all sorts of different fields. I am housed in the psychology department as a human factors engineer. I have human factors friends who are housed in industrial engineering department, systems engineering department, computer science departments, all across the spectrum within academia, and then especially out in the real world. And you can see that human factors is going to span everything from the individual, the person, to the organization, from the cognitive, so what's going on in somebody's mind, to the actual physical. And so a good human factors engineer is incorporating all of these different disciplines and concentrations, but is also working with all of these different disciplines and concentrations. And so when you're thinking holistically here, you're really employing what we would call like a systems thinking, right? So systems engineering is thinking holistically about the process, about the product, etc. And wherein you have this holistic thinking, you're having to think about things like interconnection. So what are the consequences of changing one feature? What other changes are going to result in the other connected parts, right? And so you think about computers now, almost everyone in life operates their computer with the graphical user interface and with their mouse. However, that hasn't always been the case, right? So computers used to be controlled with essentially inline, right? So if you have a Windows computer, go open the command line, or in an Apple computer, go open the terminal, and you can see what it's like to actually manipulate your computer via that. However, with the development of things like the mouse, you can get more of these graphical user interfaces to make it more user-friendly, right? So changing one feature can result in many subsequent changes, but you can also, by changing one feature, introduce a whole bunch of bugs later on in the process. You also have the adaptation component that you need to consider. So as people adapt to that new technology, you've got, I think this is supposed to say bad rather than bad, but bad outcomes for good technology, right? And so think about self-driving cars. If you have a self-driving car employed now, they're imperfect systems. However, getting behind a self-driving car can result in what we call automation complacency, right? People begin to overtrust the system, stop paying attention to it, don't monitor it for improper or unsafe behaviors. It could also result in diminished situation awareness, which can all have catastrophic outcomes for the user. And then there are also components of the environment that are guiding our behavior. And let me show you a couple examples. I forgot this link doesn't work anymore. But when you see this pad on a door, Liam says, reminds me of all those people who don't pay attention in self-driving cars. Exactly. Yep. Those are examples of automation complacency. And it's why you get some fatal accidents with Teslas, wherein people should have noticed that the car was running off the road, but they didn't because they weren't paying attention. So when you see this pad on a door, what do you think? What action are you going to perform? Exactly. Yeah, you're pushing the door, right? This plate serves no functional purpose other than to convey information about what you should do in your environment, right? It is an environmental context cue to tell you how to interact. It's why sometimes when you have doors with handles on both sides, it's really confusing and you're prone to push a pull door or pull a push door. And so the environment is absolutely dictating how you are interacting with your environment. Now, one question I get from a lot of engineers specifically is, why can't we just use our intuition? Or I know how people think, or maybe I'll design a system and then just train people on the right way to use it. And these are just 3 examples. And one of the things you'll notice is if you start looking for this, when we finally get out of quarantine and we can start going elsewhere, you'll notice just how many stupid designs there are. There may be even stupid designs in your house right now, or on the computers you're using, or with things like Zoom, etc. One of the stupid things about the design of Zoom that we started to realize with moving everything online is that, I don't know if you can see it, but my ID is displayed on the very top of my screen here, such that if I'm recording a lecture and that ID pops up and I'm using that ID as the meeting room ID, it allows people who don't belong in the class to access that recording, find my ID, and log into the recording next time. And that's what's led to what's kind of colloquially been called Zoom bombing, right? Where people are displaying inappropriate content or pushing out malware, etc. And so it's something you don't think about until a human finds a creative way to exploit it. But let's show an example here, right? This is a handicap ramp. However, at the very base of this handicap ramp, you have 2 steps. The purpose of a handicap ramp is for people who can't go up steps to get up to a higher level, right? And so thinking about the architect, the engineers, the actual construction workers that put this together, nobody thought that, oh wait, if this is a handicap ramp, we shouldn't make it completely inaccessible to those that actually need it, who are in a wheelchair. On the right-hand side here, you've got a design wherein at the top you have a slot for trash, you have a slot for recycling. However, on the actual can itself, it says recycling, right? And so because this is the most prominent, you're liable to have people looking around for a trash can, see that says recycle, not paying attention to the fact that it has this kind of subscript up top here, denoting trash, and continuing to look around for a trash can, right? And so this is a case wherein somebody, in putting this together, use their intuition of, yes, this will be clear. I've labeled trash up here, they'll know it. But in reality, you're going to have people paying attention to this recycle, the symbol, the word, without actually noticing that there's trash up here. There are also cases wherein these types of trash cans get sent out to places. However, instead of using 2 different cans inside, the workers just put a single can, right? And so now you've created this issue wherein you can throw trash in one side and recycling in the other. However, they get combined into a single can on the bottom, right? And so thinking about what are the actual designs of the system that we could put into place to prevent people from actually screwing this up. And on the left is one of my favorite examples that a lot of you have in your house right now. It's this configuration of burners on the back display. And there are 2 things that are wrong with this. First, there's no obvious mapping, just looking at it, of which burner goes to which control knob, right? And so if you look down here, it looks like maybe they have a pictorial representation, but there's no obvious matching onto it. My stove at home right now is the first stove I've ever had that has knobs down here that map on spatially to which burner they control. Here, you are substantially more liable to turn on the wrong burner and wonder why your pot isn't boiling. I've done that a lot with stoves like this in the past. The other thing I love about this design, love in a bad sort of way, is that if you have a fire on the stove, the first thing you're supposed to do is turn off the source of heat. Well, where's the source of heat? It's coming from underneath. Where's the control for that? It's behind the fire. So now, to do what is the safe approach to stopping a fire from spreading, you have to reach through the fire and try to get the right knob, right? And so now you've got a conflation of, which knob is the correct knob, and you have to reach through the fire, right? And so this is just a horrifyingly bad design of the system. So look around your environment now, currently, and then when we finally go back out into the real world, and look for examples of really bad designs. You will see them everywhere. It's shocking how bad of a design there are. And even, for example, in the old iPhone, I don't remember which model it was, but the iPhone was designed in such a way that the antenna was in a place where the average user's hand would cover it up. And what was Apple's response to that? Well, hold the phone differently. They didn't redesign the system. They just told people to hold the phone differently rather than understanding that when they're putting the antenna in the phone, they need to think about, okay, where should that antenna not be as to prevent covering it up. And so within human factor psychology and psychology in general, a lot of people say, well, psychology is just obvious, right? It's the study of things that we all kind of know. And to highlight how wrong that is, I want to show you some contradictory aphorisms out in our daily world. Aphorisms are just kind of these quotes that we use to define our understanding about the world. And you'll see what I mean when I say contradictory. So for example, absences make the heart grow fonder, but out of sight is out of mind. Well, which is it? If your girlfriend or boyfriend moves cross country, are you going to like them more, or are you going to kind of forget about them? Look before you leap, but he who hesitates is lost. Okay, so which is it? Should I be cautious, or should I just act? A penny saved is a penny earned, but don't be penny wise and pound foolish. Right? Okay, so which is it? Should I be concerned with saving every little bit or being really meticulous in my approach to things, or don't sweat the small stuff, essentially? Haste makes waste, but a stitch in time saves 9. Okay, which is it? Birds of a feather flock together, but opposites attract. Okay, well, which is it, right? You hear this all the time, and this makes me laugh every time when people say, oh, they were made for each other. They're complete opposites. And then you also hear other people say, well, they're made for each other. They're identical. Okay, we're using these aphorisms to backfill rationale into our day-to-day life. And then you have the final one here. The best things in life are free, but there's no such thing as a free lunch. Okay, well, which is it? You know, you can't have both of these, right? And so it's serve to highlight, this is just a small section, and you can probably think of other ones wherein we have sayings that we believe are self-evident, right? Observations in the world, but in reality, we have so many sayings that contradict each other. It allows us to lull ourselves into the belief that our intuition's right. And our intuition is sometimes right, but it's frequently very, very wrong. Again, just think about the actual design of that F-35 helmet. Each helmet costs $600,000 and is supposed to be specifically fit for each pilot, such that once they're done with it, nobody else can use that helmet because it was specifically fit for that pilot's head. And yet, despite the billions and billions and billions of dollars and the thousands of people that worked on this project, nobody thought, this helmet's a little heavy. What happens if you eject with this helmet on? Well, you may snap your neck and die, which kind of defeats the purpose of having an ejector seat. All right, so much of psychology, so much of human factors is trying to convince people that no, their intuitions aren't right. And I really love this quote from Steve Jobs. Your customers don't care about you. They don't care about your product or service. They care about themselves, their dreams, their goals. Now, they will care much more if you help them reach their goals. And to do that, you must understand their goals as well as their needs and deepest desires. Again, this just serves to highlight that for any of y'all going out into industry, it's really likely that you're going to develop some sort of affinity or affection towards your product, right? You think your product is the best. You want to sell people on your product. But in reality, people don't really care about your product. They care about themselves. Now, if your product can help them achieve what they're looking for, great. You're up and running. But you need to really think about the human, the user. Think about all the ways they can use and misuse your product. How do we design it to be safer, but also something that enhances satisfaction? What are the things that we need to consider in enhancing the performance with the product? And so where do human factors folks work? Well, obviously in academic positions, like I am in now, doing research and teaching. Also employed heavily in the government, so things like military equipment design, system design, website design, um, industry, so having website design, product design, T&E, test and evaluation. You know, I have human factors friends working at Facebook, Lockheed Martin, other defense contractors, NASA, Apple, DirecTV, Microsoft, Navy, the Air Force, Army, etc. Right? So really spanning the um, the various sectors in the economy. If the product or the organization is for people or employs more than one person, human factors engineers are needed in all of these domains to enhance the safety, enhance the performance, and enhance the satisfaction. And I've already talked about my research at the beginning, and so I'm not going to bore you with all the details about my research, but if you do want to hear more, you want to potentially get involved in my research, you know, reach out to me in the fall and we will absolutely get you involved in my lab. If you are interested and if we have the space, you know, we've been very lucky to have a lot of applicants in years past. Because what we're doing is focusing on the human-machine teaming, human-machine interaction. How do we design robots to elicit much of the same interactions that we have with other humans, make it a seamless transition? How do we design a self-driving car that doesn't enhance trust, but it calibrates trust, such that the user, the driver, isn't off reading Harry Potter when they should be monitoring the self-driving system? How do we help artificial intelligence understand the human? What's the information we need to feed into these AI networks to help them understand the human's emotional state, their trust, etc.? And so here is a good, just kind of little excerpt about driverless cars. And then I'm not going to have you do this because I think this is better done in class, or excuse me, like in person. But this is a BBC documentary about the Asiana flight that crashed in San Francisco, I think it was like 10 or 15 years ago. And go through it and think about, okay, what are the task design differences or equipment design differences, environmental design, training, selection, team organization, design changes that need to be made in order to enhance the safety, right? And so you can even think about kind of the cultural influences. One of the things they talk about, I don't remember if it's in this little excerpt or in one of the other ones I've watched, but how the, I think they were Korean pilots, and how in Korean culture, there's a very strict hierarchy where you're not really supposed to question your elders. And so the co-pilot didn't want to, even though he knew something was going wrong, didn't want to question the pilot in charge of the aircraft because it would be seen as disrespectful, right? So what are those actual human factors changes we need to make in an organization, within a task, equipment, etc., to enhance the overall safety? And so with that, we are done about 15 minutes early. Thank you all for an awesome semester. I appreciate y'all's flexibility in moving to everything online here. It's been a weird time, certainly one for the history books, but I really appreciate how flexible all of you have been. I will send out the information about when our final is, but all of that information is publicly available, so you can look that up before I get that to you if you are so inclined. Again, on Tuesday, we will be having a review session for the final, so please have studied and come with specific questions. So I'm not doing a full recap of, for example, human factors. So yeah, come with those specific questions. I'm going to stick around for the rest of the period here until everybody signs off. So if you do have questions, let me know. Otherwise, I will see y'all on Tuesday. Have a good weekend.